Well, thank you for joining me on this exercise. I'm going to look at question 5, and it says an open box is made by cutting squares from the corner of a rectangle sheet and folding up the resulting flaps to form the sides of a box. Use calculus to determine the maximum capacity if the original card is 25 by 40 centimetres. So I'm going to look at 5A, and it's 25 by 40 centimetres. All right, so we've got this box. We don't know how big the corners are, so let's just put 4 corners. We'll call those corners X that we've chopped out of each corner. And we want the maximum capacity. Well, what is the capacity? If you fold this box up, we've got slightly smaller dimensions. We've got 40, take away 2 x's on the length, and 25, take away 2 x's on the width. So 40, take 2 x's on the length, and 25, take 2 x's on the width. And the height of this box would be x, because that's the dimension of the corners. So let's look at the capacity, and I will use C, and the capacity is, if it's cubic centimetres, capacity is millilitres. And so millilitres and cubic centimetres are matching. So let's take the volume, and it is length times width times height. All right, let's expand that. So we've got 1,000 minus 80x minus 50x plus 4x squared, and we've still got that x. So we've got 1000x minus 130x times x is x squared, and plus 4x squared times x is x cubed. So what we've done is we've multiplied the x times each of those. And we want to get the derivative, dc dx, and let it equal to 0, and solve that. So dc dx would be 1000 minus 260x plus 12x squared. So let's divide everything by, let's say, divide everything by 2 for now. So 500 minus 130x plus 6. We can divide it by 2 again. So we've got 250 minus 65x plus 3x squared. Okay. Now, if we factorize this, we've got a and c is 3 times 250. So 2 numbers that multiply to give ac. Add to give b, which is negative 65. So, that's to negative 65, 75 times 100. So let's look at our factors here. We've got 25 times 30, that would give 65. Let's see what else we've got, 750. Calculator. And let's say 750 divided by 750 divided by something smaller than 25, let's say 15. There it is, negative 15 and negative 50, negative 15 plus 50. So we can factorize this to be 3x minus 15, 3x minus 50, all over 3. So I've got the negative 15 in here, negative 50. And I use, because it's plus 3, I put a 3x over 3. Now we can cancel that 3 with this bracket. Therefore, x will equal 5, or x will equal 50 over 3, which is about 16.6 recurring. However, 16.6 recurring won't work because we don't have enough. So this is the only solution. For 5 is the best solution. We can test this into our second derivative just to see if it's going to be a maximum or a minimum. So d2c dx squared will be negative 260 plus 24x. And if we put a 5 in there, therefore it's negative 260 plus 5 times 24 is 120, and we've got a negative 140, which is a negative. Therefore, it's going to be concave down, so it's a maximum at x equals 5. What was the question? Determine the maximum capacity. Okay, so now to answer the question, what is the maximum capacity? We have to substitute 5 in our formula. Capacity is 1000 times 5 minus 130 times 5 squared plus 4 times 5 cubed. So this will give us our final result, which is 1000 times 5. So that's 5000. 25 times 130 gives us minus 3250, and 125 times 4 gives us an extra 500. So we've got 5500 minus 3250, and our maximum capacity is 2250. Now originally cubic centimeters, but we want capacity, so the most we can fit in that is 2250 milliliters. Well, I hope this has helped. Until next time, stay happy.